All right, well, we've already made it to problem set number 3. Here's a few examples to help you out. Example number 1. Compare these two. So one of these is going to be, in case you didn't know, we're going to take the derivative. That's calculus. Okay, anyway, when you take the derivative, one of these is going to be the product rule, and one of them is going to be the chain rule. So which one do you think is the product rule? Did you choose that one? If so, you got it right. This one is the chain rule, because this is saying the sine of x function got substituted into the sine function, because this has no x right here. Since this has an x right here, it means you have one single sine x function times another single sine x function. And for this, you could go ahead and do the product rule, but because this one is sine times sine, I could also say that is sine squared. Then take the derivative. So first of all, do the power rule. The 2, you bring it in front and multiply. Subtract 1 from the exponent, and we're left with this. Now do the chain rule, which says, by the way, you never took the derivative of this sine, so you need to do that. The derivative of sine is cosine, and that would be the answer. Now, if we did the product rule instead, so go back to the beginning, the product rule would look like the derivative of sine is cosine, so that's the first one, and then leave the second one alone. Then plus, leave the first sine alone and take the derivative of the second one, which is cosine. And then this would be sine times cosine, plus another one that's sine times cosine, which means that you have two of them that are sine times cosine. And then, since we're here, might as well just remind you, you could also have the answer sine of 2x. Because remember from trigonometry, the trig identity for sine of 2x is 2 sine of x cosine of x. So if I were asked to find the second derivative, I would switch it over to this, because if you go to find the second derivative, or in other words, the derivative of this, you would need to do the product rule, and it would actually be less work if you change it to this and then do the second derivative. Well, just for extra fun, let's do the second derivative. So then the derivative of sine would be cosine, and then do the chain rule, take the derivative of this 2x and multiply. And then that would be the second derivative, just one extra step. Then for this one, take the derivative. The derivative of sine will be cosine. And then what's in the parentheses has to stay exactly the same. Now do the chain rule, which says, okay, sine of x right here, now it's your turn. The derivative of this sine of x is cosine of x. And with this one, we're done. There's no way to simplify, because this is not saying cosine of x times cosine of x is cosine squared, because this one has sine x as its argument. This one only has x as its argument. So this one is finished. And this one was finished right there. All right, then on to something that's not trigonometry. Number 2. So for example number 2, how about it's natural log of x plus y equals an a. Now if it was, well, I'm just going to say it. This a right here is a function. So this is a function of x, a function of y, and this is also a function of x and y, although we don't know what it is, but it's a function. And then find the derivative, more specifically find dy dx. So you can say y prime, and that's just fine. That's the shorthand notation. Like if somebody has a nickname, that's their nickname. And this is their full name, because this gives you more information. This is saying that y is the independent variable and x is the dependent variable. The reason for that, just a moment. So take the derivative. The derivative of the natural log function is 1 over whatever's inside the parentheses. Then do the chain rule. Take the derivative of what's in here. So that's going to be the derivative of x is 1. And then the derivative of y, you can either use y prime or dy dx. I'm going to use y prime. Now because this is a function, we need to take its derivative. But I don't know which function it is, so I just have to say, take the derivative of a. And now we need to do some algebra to solve for this y prime right here. So what I'm going to do is take this x plus y, multiply both sides by it. When you multiply this side by it, they'll cancel. Basically, I'm just transferring it over to the right side. And you don't need to multiply that out. You can leave it like that. And then, and after a brief video edit, all I needed to do was subtract 1 from both sides, and then that's y prime. All right, now on to example number 3. So these last two examples are going to be about related rates. So suppose that this is the ground and this is a wall. And then we've got this piece of metal that's 15 feet long and it's leaning up against the wall. So it could be leaning like this. And then somebody's gonna come and push it, and that's gonna cause the top, if I can do it right, that's gonna cause the top to go up. Okay, so because this side is gonna change, I need to use a variable like x. And also this vertical side is gonna change, so I'm gonna use y. And then find a derivative. Well, the derivative I'm going to be looking for is take this angle right here, which is the angle of elevation going from the ground up to this line right here, and find d theta dt. So in other words, as that thing is going up, how fast is the angle changing? So find d theta dt if dy dt is equal to 2 when the theta is equal to 35 degrees. And by 2, I meant 2 feet per second. Now, if this was asking for dx dt or dy dt, I could use the Pythagorean theorem, x squared plus y squared equals 15 squared. But because it's asking about theta, that means I need to use trigonometry. Also, this has y information, so I need to use a trig function that uses this side and one of the other two sides. It would be easiest to use the 15, because when you have a constant and you're taking derivatives, there's nothing easier than that. So I'm going to use this side and this side. So this would be opposite and hypotenuse. That is sine of theta. So sine of theta equals the opposite over the hypotenuse. And then take the derivative on each side. Over here, the derivative of sine is cosine. And then do the chain rule. You now need to take the derivative of theta. So you could either write d theta dt, or for short, you could just write theta prime. And with this, I do not need to use the quotient rule because 15 is a constant, so it could just sit there while I take the derivative of y. So I was asked to solve for theta prime or d theta dt, so I need to solve for this. Then I need to plug in a number for theta, and I need to plug in a number for y prime. Those two numbers are sitting right here. So then it's going to be cosine of 35 degrees times the theta prime equals 2 over 15. Or if you divide both sides by cosine of 35, it's going to look like 2 over 15. Then that gets divided by cosine of 35 degrees. So, trust your calculator. Right now it's in radians, so I need to change that to degrees. And then 2 gets divided by both the 15 and cosine of 35 degrees. So the theta is changing at 0.163. Then what are the units? Well, this was in feet per second, so it's going to be per second. And this is degrees, so that means it's degrees per second. And there's number 3. Okay, now for number 4. So this one takes quite a few words, so I went ahead and wrote it out. The Bailong elevator. Hopefully I'm saying that right. Bailong elevator. This is the world's largest outdoor elevator. It's in China. It is 1,070 feet tall. It's sort of next to a mountain, so it's like a where tourists go to take it up to the top of the mountain. And it can take 50 people, which that part doesn't matter, but it only takes 2 minutes to get to the top. Now let's say that somebody is standing 800 feet away. They're waiting their turn, there's a line. This thing takes up to 20,000 people a day. Anyway, so they're waiting in line, they're 800 feet away from the base, and of course, they watch the elevator go from the top to the bottom, from the bottom to the top. So how fast is it changing after 1 minute? So because it's 1 minute, that means they're going to be halfway through, and it doesn't, because it's halfway, it doesn't really matter if it's going to the top to the bottom or bottom to the top, because it's halfway. All right, let's say that this is the ground and this is the elevator. And I'm not going to put the 1,070 feet because the elevator is going to change. So it's going to be right here at one moment, it's going to be right here. At some moment, it's going to be right here. And then the person is looking up at the elevator and they're watching it. How fast is the angle of elevation changing? So angle of elevation would be like with the last example, that's this angle right here. So from the horizontal, then look up to the elevator, and this is the angle of elevation. Well, like with the last one, since this is going to change, I need to use a variable right here because the elevator is going to be going up. We also need to assume that this thing is standing upright so that that's 90 degrees. Now this over here is the person standing 800 feet away. So the person is standing over here waiting in line. 4 years of art school pays off, huh? And this is not going to change. They're going to be standing 800 feet away. So this I could go ahead and put as 800 feet. And the question does not ask anything about the distance between the person and the elevator. So I don't really need to put anything right there. Well, that means we're going to be using these two sides, which is opposite and adjacent. So that's going to be tangent. So tangent of theta equals the opposite over the adjacent. How fast is the angle changing? So that means we're looking for the derivative of theta. And that means we should go ahead and take the derivative. So the derivative is going to be derivative of tangent is secant squared theta. And then the chain rule, take the derivative of theta. And then y is going to be, well, I need to take the derivative of that. So it's going to be y prime over 800. Now, if we're going to be solving for this theta prime right here, then we need to know what does theta equal and also what does y prime equal. Well, y prime is how fast it's going up. And for the purposes of this, we're just going to have to assume that it goes up at a constant rate. Most likely it's a little bit slower at the beginning, because if you start an elevator too fast, people will fall down. But let's just assume that it goes at a constant rate. By the time it's in the middle, it's probably at a pretty constant rate. So what's the rate? It goes 1,000 feet every 2 minutes. So in other words, y prime is equal to 1,000. I think I said 1,000. I meant to say 1,070 feet every 2 minutes. So divide by 2, that would be 535 feet per minute. So we have the y prime. Then what about theta? Blah, 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 words, after 1 minute. Well, if it's 1 minute, that means they're halfway up. So all of this was done for the calculus. Now I need to do a little bit of trigonometry. So the person is still 800 feet away. After 1 minute, that means they're halfway up. Well, I actually just did the dividing right there. After 1 minute, that means they are 535 feet up the shaft of the elevator. And then how much is theta? So this is going to be tangent. So tangent of theta is equal to 535 divided by 800. And then take tangent inverse. So working in degrees, that's going to be fine, because I'm going to be substituting it in here. All right, so what is tangent inverse of a 535 divided by 800? It's 33.773 degrees. So now I can substitute that in here. So it's going to be secant squared of the 33.773 degrees times theta prime. And then the y prime is this 535 over 800. That seems to be showing up quite a few places, doesn't it? And then theta prime is going to be 535, which was divided by 800. And then I need to divide both sides by this secant squared. So it's going to end up in the denominator over here. And last, just type that into the calculator. So 535 gets divided by, and then I need to put parentheses. It gets divided by an 800. And my calculator doesn't have secant, so I need to change this to 1 over cosine. So then it's going to be parentheses 1 divided by cosine, 33.773, and then that needs to be squared so that it's secant squared. And because I put parentheses at the beginning and the end, that means all of this is in the denominator. And then the 1 over cosine will be secant, and then I've got the squared. So the angle is changing at 0.462 degrees, and then that is per minute. All right, that's my examples for problem set number 3.